Hello, everyone. So I'll be talking today around closeout and synthesis for Project 2.7 on refining Australia's water future. So my name is Francis Chiu, and I co-lead this project with David Kirono, and we got a bunch of good researchers in this project working with us, and we also partner with stakeholders, the Murray-Darling Basin Authority, and the Western Australia Department of Water and Environmental Regulation. So the focus of this project is around providing hydroclimate projections so that we can assess climate change impact, the risk, and adaptation options. So there are things that are currently available now. So we are aware of climate models that are around, the global climate models, the regional climate models, the impact models, in my case, working a lot with hydrological models and land surface models. And there are also sources of projections data. I think the problem is most of these are for long-term averages, whereas as we know, things happen at the extremes, could be dry conditions over several years, or could be the high flow and low flow characteristics. So what this project is doing is trying to fill in the gap and find methods to provide hydroclimate metrics that are relevant for applications that got to be sorted out. And so we try to develop a framework for this in this project, as well as address some of the various science, challenges, and applications. So how we address this problem? So the first step is doing a literature review and engaging with stakeholders to understand the user needs. And having done that, the second step then is improving and undertaking integrated climate water modeling and projections. And we also developed and implemented 2 research case studies with the water sector. So the first aspect of the project was on understanding the user needs. This was carried out by Marie Ekstrom, where she undertook a literature review of things that are around in Australia as well as overseas, talked to stakeholders, and also done a whole series of surveys and categorized their needs into metrics in the 4 categories relating to timing, magnitude, state of the water systems, and the service and performance, and also understanding the other drivers of the metrics beyond the climate drivers, and then coming up with the modeling challenges in developing these metrics, which we address in this project here. And I'll present a couple of slides relating to these. So the first slide is really simply updating projections of long-term averages to rainfall, potential evaporation, temperature, and runoff here. In this case here, the plot shows projections out 30, 40 years from now, relative to now for the highest emission scenarios coming up from the latest set of CIMIC 5 global climate models. So I think in terms of temperature and potential evaporation, there's a lot of consistency between these models showing warmer conditions and higher potential evaporation in the future. But in the case of rainfall, as you see in the left-hand side, on the first column of the plot, there are significant variations ranging from very dry to very wet, and these are amplified in the runoff projections in the far right column. Now we know climate change can bring about significant changes to water availability, in this case here on the far right, but they range from projections of drying all the way to wetting. However, if you look at the southern parts of the country, particularly the far southwest of Australia and the far southeast, even the wettest models or wettest results on the bottom right panel do show drying there. So there are these, and together with other evidence, point towards drying conditions in the southern parts of Australia, where we have to develop adaptation pathways to adapt to what is likely to be drying conditions in the southern parts of the country. So that's still long-term averages, but what this project then went to do is have a look at also projecting a whole range of hydroclimate metrics that, like I say, was important earlier on. So the top panel here shows changes all the way from the Q05, which is the low flow metrics, the 5th percentile flow, all the way to the right, which is the 90th percentile or 95th percentile flow, the very high flow. And so there are differences in the projections of the different water metrics, which we need to know so that we can adapt to, particularly for water-dependent ecosystems at the high flow end and the low flow end. Now, the bottom plot also shows potential changes or projections of changes to high flows, so reduction in the number of days in high flows and increase in number of days low flows, which are important for coming up with adaptation options relating to water-dependent ecosystems. That's by means of water metrics. So another phase of the project looked at drought projections. So this looked at projections for multi-droughts. So looking at the indicators, the metrics, so looking at both the duration and frequency, having a look at the categories of the drought, and looking also at the regions across Australia. In this case here, we adapted or adopted the same regions that were used in NRM or National Resource Management projections. So by means of a quick summary of the results, you see on the plots on the right-hand side, showing percentage of time in drought for the extreme drought category, for Northern Australia at the top, Southern Australia at the bottom, and the blue ones shows drought indicators relating to precipitation, and the red columns shows that are relating to the soil moisture. So whether you look at rainfall drought or soil moisture drought, we find most of the projections, although with some uncertainty, shows increase in drought risk into the future. And these are the numbers that are the projections that are needed to again address adaptation options and understanding the risk into the future. Now, the third aspect of this work, we also looked at modeling, looking at carbon, water coupling, modeling land surface models. And this work showed that the global terrestrial gross primary productivity, or GPP, has increased steadily because of the increase in atmospheric CO2 concentration. So this will affect the water use efficiency and will affect changes in water availability also. I think there's still a lot more work that needs to be done in this area, and we'll continue to address these into the future. Now, all those are the science context, but what we are really proud of is also the engagement that we do directly with the water sector. So in this case here, designing, co-designing in partnership with the stakeholders, a bottom-up, or what we call decision scaling framework to characterize the system response to changes in key climate characteristics. This is because we know that there'll be considerable uncertainty even with the improvement in science or projections into the future. So one of the key features, I think, from this work is working directly with the key stakeholders to understand, regardless of the projections, what might happen and what risks there are for different sensitivities in the climate, so that we can tie that back together with the top-down estimates or projections which are presented earlier on. So this work is actually being done with the Western Australia Department of Water and Environmental Regulation, and also with the Murray-Darling Basin Authority. And we will continue this as part of the next phase of this ESCC project in Project 5.4. So summarizing the project outcomes in the context of this framework set up by the ESCC Hub, there's a whole series of research activities in the bottom, which I've talked about, and there's a whole series of research outputs and products. And ultimately, the outputs that we have provided here ranges from, we have 5 peer-reviewed papers, a whole series of presentations, keynote and invited presentations at different places, 13 internal reports, and a couple of knowledge products. There's also a whole set of data set that we produced from these, as well as the improved knowledge and modeling capability in this project. And these are all in the Hub website's location. But I think what we are particularly proud of is also working directly with the stakeholders, as I mentioned, with the MDBA and the Western Australia DWER, co-designing research methods so that we can actually show and lead to changes in how systems are actually managed or adapted using the knowledge that's coming up from Project 2.7. So moving ahead then, this project is largely going to continue on as through the Hub Project 5.4 for the next 18 months. So there are really 2 phases in this project here. The first is starting up the work that we've done and to improve the integrated climate and hydrological modeling science, and then develop the framework for the next gen projections. This is done in very close collaboration with Project 5.3 led by Michael Gross, and this will take the opportunity of the upcoming CMIP6 global climate models by the IPCC in the next 2 or 3 years, together with more downscaling projections and tying that in Project 5.3 dealing with climate, and in this project dealing with water metrics to come up with framework for delivering the next generation of improved, robust projections of both the hydroclimate as well as the water metrics. Now, another aspect of this project is working directly with the stakeholders I mentioned earlier on, with the Western Australia Department of Water and Environment Regulation, looking at a low flow, reliability of supply to farm dams relating to environmental flows in one of their basins, and with the Murray-Darling Basin, looking at on their system resilience, tying consumptive water and ecological risk under climate change risk in the Murray River. Yeah, so that's really my story, our story to share with Project 2.7, and thanks for listening.